Yeah, I mean, it's kind of hard.
What kind of stuff are you working
For
on?
like word problems.
Okay, you're working on word problems?
Yeah, just for this, just for like,
Go ahead and
my,
read, go ahead and read one of them to me. I'll see if I
okay, so it says the function, f of x equals -16 parentheses x. So this is for a parabola. It's just giving you the parabola. And it says that gives the height in feet of a football x seconds after it is kicked from the ground level.
Okay, did I get the whole function correct here?
Oh, okay.
Is it, let me see,
It's-
David. I have Dave Cohen.
Yeah.
Yeah, it has to be spelled exactly like you see there.
Okay. But yeah, okay, so it's -16 in parentheses, x minus 1 in parentheses, parentheses out, and then little squared. So negative, yeah,
Okay,
plus 16.
plus 16.
Yep.
Okay.
Okay.
And what they're saying is that this represents the height at any time x.
Okay.
Okay. Notice that at time x equals 0, the height is going to be 0. If I plug in 0 for x, I'm going to end up minus 16 plus 16.
Yeah.
F of 0 would be equal to 0. What do they want to know?
Okay, so my mom just resent that.
I got it. Here, I can pull it up.
Okay, and it's okay, yeah. This is pretty cool.
Yeah, it's very neat technology. The only thing is that she sent it not as an attachment.
You didn't?
Yeah, in other words, I don't have the ability to shrink this so that I can see it.
Mom?
If she sends it as an attachment, then I can bring it up as a PDF file and zoom in or zoom out on it.
You can't send them as an image, you gotta send them as a PDF file.
Well, just as an attachment. See if you can attach the file to the email that she sent.
That's all I can see. You can't like minimize it.
When I talked to you before, you said just take a picture of it. You said you just woke up from a nap.
Yeah.
But anyway, you said take a picture with your phone and then just send it that way.
That's correct. But for some reason it came across as part of the email as opposed to an attachment. If it's an attachment, then I can move it to my computer and shrink it up so that I can read it a little better.
Okay, it shows on my phone as an attachment.
Okay, I can probably figure out how to do this. I can figure out what they're wanting at least.
Yeah, it says attachment.image1.jpg.
Right. Although it did not come through. If you look at my email, you can see there's no attachment. It just came through as an image. Now,
well, I forwarded it. Maybe I need to resend it and attach it.
I would take the picture, and then once you pull what kind of phone do you have? Is it an Android or an iPhone?
iPhone.
Okay. You need to send it as an attachment and send it as a large image attachment.
Okay, I send it as actual size. So let me try one again real quick.
Right. Okay. Yeah. You'll have two choices. You can do the smaller image or the larger one. Make sure you do the larger one. But if you do it as an attachment, it ends up here. Let me show you what my last student. He sent it, and this is what I got. Okay. And then I can download each of these to my, these are both JPG files, but I'm able to put them on my computer, and then I can blow them up or zoom in as necessary. Whereas with the file you first sent me, I can't do that, but with this one I can. So whatever you did there is what...
The last one?
The last one worked perfect. That's exactly.
Okay, I did it the same way, but the previous three, I forwarded it from the last time I sent you. This is just an original one.
Oh, so that's the difference. Okay. Well,
Make sure.
notice on this one I can zoom in and out now, which is what I need to be able to do.
Great.
Okay.
So
So it's not that one. There should be 3 that you get.
okay.
I'm in the second one now.
Yeah, she's sending them right now.
Okay.
Sorry about that.
That's all right. What was the question that they wanted to know here?
Okay, so the B is asking what is the maximum height that the ball reaches?
Okay. Okay. We know that parabolas are what you get when you graph quadratics.
Mm-hmm.
This
Yeah.
is quadratic because it's x squared. So
Yep.
we know it's going to be a parabola. We also know it's going to point downwards because of that negative sign right there.
Yeah.
So it's going to look something like that.
Uh-huh.
Okay. What they want to know is that right there.
Yeah, so it'd be 16, right?
What's that value? Well, we don't know. We have to figure it out. That is the vertex of the parabola, though.
Okay.
Okay? So if we can figure out the coordinates of that point right there, we'll know the height. We'll know at what time it occurs, and we'll know how high it is.
Okay.
Well, notice they've given this to us in vertex format.
Mm-hmm.
Remember what vertex format was? It was a times x minus h squared plus k.
Okay.
H is the x-coordinate of the vertex, k is the y-coordinate of the vertex.
Yeah.
So what are my coordinates on that vertex?
What are your coordinates?
Huh? In other words, what is h and k? That's the vertex.
Let me...
No, look at the function. It's that format.
Uh-huh.
H and k are the vertex.
Uh-huh.
So compare that to that.
Okay.
What's h going to be?
H is going to be...
1.
Yeah, I'm just not sure because it doesn't have numbers.
No, hold it. Here's our format. X minus 1 squared.
Uh-huh.
Well,
okay. It would be negative 1. Okay.
X minus h squared.
Mm-hmm.
So h must be 1.
Okay. Okay.
Okay.
I know what you're saying.
What's the y-coordinate of the vertex? That's what k is.
The Y, 0?
What's that? That's the k right there.
Okay. Okay.
Okay, which is 16. But
That's the Y.
let's go back a step here. Let's make sure you understand how we're getting this.
Okay. I was just a little okay.
I understand. Okay. This is the general format of any quadratic parabola, whatever you want to call it.
Okay.
Where h is the x-coordinate of the vertex,
Mm-hmm.
and k is the y-coordinate of the vertex. So looking at that is our specific parabola.
Mm-hmm.
What's h and what's k? Compare that to that.
Okay.
Do you see why
yeah,
h is 1?
Okay, yeah, so H is 1, yeah.
And k is...
K is 16, okay.
Okay. So what that tells you is that 1 second after this thing is launched, or thrown, or a rocket, is it a rocket? Is it a ball? What is it? It's something
it's
going up in the air.
It's the ball in the air, yeah.
Okay. Well, 1 second after it's thrown, its height is 16.
Okay, okay.
In other words, what we're looking at is a parabola that looks something like this, and that comes at 1, and that value is 16, because the coordinates on that thing are 1 on the 16. So
that makes sense.
What you always need to do to solve these kind of problems is figure out what the coordinates of the vertex are. And this was particularly easy because they gave us the function in perfect vertex format.
Yeah.
They didn't give it to us as a quadratic x squared minus 2x and so forth and so on, which would have required a lot of work for us to find the vertex.
Yeah.
When they give it to you in vertex format, it's real easy to find the vertex. There's H, there's K. That, incidentally, is A.
Yeah.
But that doesn't have really any bearing on this. In other words, not yet. That's for their first question. What's their next question?
How long does the ball stay in the air? Explain how you determine your answer.
Okay. The ball stays in the air from the point that it's launched up to its peak until it comes back down and hits the ground. Well, what is y at this point right there?
2.
No, what is y? We're on the x-axis.
What is
What is the y coordinate of that point that I've circled? We don't know what the x coordinate is yet, but we know what the y coordinate is because it's on the x-axis. What are all y measurements when you're on the x-axis?
0.
Yes.
Okay.
So we have to solve this equation, substitute 0 for that, and figure out what that's going to tell us what both of those points are.
Okay,
that'll tell us how long it stays in the air. Well, if I move this 16 over and do the algebra, we've got minus 16 equals 16 times x minus 1 squared. Divide both sides by 16. Oops. Plus 1 equals x minus 1 squared. Take the square root of both sides. You get plus or minus 1 equals x minus 1. And finally, x is equal to plus or minus 1 plus 1. Now, if you find all that confusing, I'd be happy to go through all of this algebra. But this algebra should be fairly straightforward.
Oh, yeah, no, that's fine.
Okay? In other words, whenever you take the square root of both sides of an equation, you have to start your answer plus or minus 1. That's where I got that.
Yeah.
And then I'm merely adding 1 to both sides.
Yeah.
And what this tells me is that x is either 0 or 2. So that's the solution. I get x equals either 0 or 2. Well, the 0 was actually when it was thrown. So I haven't quite drawn my picture perfectly. The picture really is more like this. And it's giving me the x-intercepts. One occurs at 0, the other occurs at 2. So that means it hits the ground at 2 seconds. We're going to throw out the 0 because that's where it started from.
Yeah.
In other words, it's giving you the 2 places where y is 0. And y is 0 before it's thrown and after it lands.
Okay.
Okay? The 0 is before it's thrown. That's where it's at.
Yeah.
And after it lands is this point here. And so it's in the air for 2 seconds. What else do they want to know?
That's all they want to know for that.
Okay. Here, let me pull up my email here and see if I got more emails. I did. Okay. Let's have a look at this one.
Okay.
And here, let me just pull all 3 of them out as long as I got it. That's kind of weird that that program works that way, where if you're forwarding it, it doesn't forward it as an attachment. Forward it as an image. Is this the page we want?
Oh, that's the next one, yeah. But this one, I just wanted to go over that first one.
Okay.
But that one, yeah, that one is the one I'm on.
Okay.
It's just like
Let's
the
talk,
word problem.
let's talk about word problems, because a lot of people have problems with word problems. And there really is a very simple way to get a handle on word problems.
Mm-hmm.
And that simple way is always define your variables as your first step. If you do that, the word problem will almost work itself.
Mm-hmm.
Okay? And the way you define your variables is always by looking at the last sentence first.
Okay.
How many adults and how many children were admitted to the movie theater that day?
Mm-hmm.
Well, let's come up with some variables. How about x equal what?
Or x equals adults and...
Or A and C are fine. I'll use the variables you put there. But
yeah.
I might add one thing is A doesn't equal adults. A equals the number of adults.
Okay.
And just adding that verbiage helps a lot.
Mm-hmm.
Because sometimes you'll have your variable equal the price of an adult ticket.
Yeah.
Okay? Or the price of a child's ticket. Well, in this case, it really helps if you are very specific with how you define it.
Okay.
Okay? So if A equals the number of adults and C equals the number of children, then now I go back to the first part of the problem and try to come up with an equation.
Yeah.
Well, what's one equation? Start with the first sentence.
Okay. So,
the number of adults times what?
Number of adults times $7.
Right, times the price of an adult ticket.
And then
that's going to give you all of the income from the adults, right?
Mm-hmm.
Plus what times?
Plus $5 of C.
Equals
the $4,600.
That's how much revenue you get. In other words, you take the number of adult tickets you sold, multiply it by 7, the number of children's tickets you sold, multiply it by 5, add those two together, that gives you your total revenue.
Yep.
Now, we have one equation but two variables. You can't solve that.
Yeah.
You need another equation.
Mm-hmm.
What's the other equation? I see it written right here.
Yeah, so just A plus C equals 800.
Exactly. There's our second independent equation, and now we can solve a system of equations quite easily.
Mm-hmm.
The best way to solve these two equations.
What's the best way?
Yeah, do you want to use substitution or do you want to use elimination?
What would you use? Substitution?
Elimination.
Elimination?
Whenever my two equations come in standard format,
okay,
I'm going to use elimination. And standard format is your variables are on the left, your numbers are on the right.
Okay.
The reason is it's relatively easy to eliminate a variable. I can't do it yet because the only thing I can do is add these two equations, subtract them, or I can multiply one. What if I took the bottom one and multiplied both sides by -5?
Mm-hmm.
Allowed to do that. Okay. So now equation 1 is still there. There's equation 2. I like to number them because sometimes you can end up filling up the whole page with equations and you get lost. So equation 2 is now what? After I multiply everything by -5.
Equation 2, 25 plus...
-5a.
Oh, my bad. Plus negative 5c.
-5c, right?
Minus 5c, yeah.
Equals
negative 4,000.
Okay, so that's my new equation 2.
Okay.
Now I have my equation 1 and my equation 2. What can I do to eliminate a variable? And I don't care which variable I eliminate.
Okay, eliminate the 5s. 5C.
I can add the two equations. In other words,
Uh-huh.
always can add equations or subtract equations.
Uh-huh.
Can't multiply equations. But if I
Yeah.
tell you that A plus B equals C and X plus Y equals Z, I can add those two together so that A plus B plus X plus Y has to equal C plus Z. I can always do that,
Uh-huh.
no
Yeah.
matter what the equations are. Okay?
Mm-hmm.
So if I add equation 1 to equation 2, what do I get down here?
So we get 2A plus or equals negative
Yeah, that
4,000.
goes to 0, and hence the
Yeah.
name elimination. That's why it's called elimination. But
Mm-hmm.
now you have to add that to that.
Oh, okay. Okay, yeah.
In other words, if I'm going to add these equations, I got to add the left sides together, and I have to add the right sides together.
Yeah, I just didn't, yeah. Okay, so it'd be 600, yeah.
So A, which is the number of adults, is 300.
Yeah.
What's C?
C,
Which equation am I going to plug it into to solve for C? I got three choices. I can
A plus C
I can
equals
use
A
the
plus.
original. I want to do the easiest one I can do.
Yes.
Okay? There's my three choices.
Uh-huh.
I can plug it into this one, or this one to solve for C. Which one would you use?
A plus C equals 800.
So what's C?
A, so C is 500.
There's your answer.
Okay.
Notice that the moment you define your variables, the rest of it kind of is pretty easy.
Yeah, that is not hard.
No,
Oh my
just
God.
make sure you define your variables specifically. It's always the key. In other words, it would be very easy to get confused here. If I didn't put that in,
Yeah, that's what my teacher stressed.
Is A the price of an adult ticket, or is A the number of adults?
Yeah.
It matters. So we want to make sure that we define it very exactly.
Okay.
Let's see. It's 6 o'clock, but I don't mind doing one more of these if you want.
Okay. This is just a half hour.
Yeah, well, that's what I had on the docket.
That's fine.
Because I have you down again for 4:30 on Thursday.
Yep, sounds good.
Okay.
Can we just do number 5?
Sure. Again, first step, always on all word problems.
Define variables.
Yes, as long as you do that, you will not have a problem. And I see that you've kind of done it here.
Yeah.
And we got that by the perimeter is 72. What are the dimensions of Sally's garden? In other words, in order to define the variables, is all we have to do is look at the last sentence.
Yeah.
Yeah. Well, dimensions, the only dimensions that she could be talking about, it's a rectangle, so it has to be length and width. So L equals the length, and you don't maybe need to say the length of the garden. In other words, that's pretty specific, saying L is length and width is W. Okay, so now that we've got our variables defined, let's go back to the first sentence. This is the way you kind of do all word problems. You start at the last sentence, and then you go back to the first sentence. So starting the first sentence, put that in an equation.
Okay, so the first sentence, just 3W.
Is means equal.
Okay.
So how do I say the length equals 4
so would it be
greater than 3 times the width? What equation is that?
So it'd be L equals 4 plus 3W.
You got it. That's equation 1. Again, I can't solve it with just one equation, so I need to look for another equation. Well, let's look at the second sentence.
perimeter
Give me
of
an equation that states that. What's the perimeter equal to? 72, but in terms of W and L.
L plus W equals 72.
It's 2L plus 2W.
2L.
In other words, here's our garden here.
Oh, okay, I got you.
That's W. That's L. The perimeter is 2 L's and 2 W's.
Okay.
Okay. Now, so now there's our second equation.
Uh-huh.
Let's erase that just to get it out of our way. Now, this one, I'm not going to use elimination because it's not in standard format.
Yeah.
It's one of the equations has one of the variables fully defined. That one right there. In other words, L is completely defined.
Yeah.
So this one, we're going to use substitution.
Okay.
And we're going to substitute into that. So now give me this second equation after I substitute 4 plus 3W wherever I see L.
Yeah, so it'd be 4 plus 3W parentheses plus 2W equals 72.
Now notice we have one equation, one variable. We're going to be able to solve for L, or rather W. Once we solve for W, we're going to be able to go back into either of these other equations and solve for L. So let's just go through this simple algebra. What's the next step in solving for W here?
So it'd just be 8 plus 6W plus 2W equals 72.
Next step?
Minus 8.
Okay, and combine your W's.
Combine those.
Subtract 8 from both sides. Finally, W equals 8.
Okay.
So the width of the garden is 8. Which equation am I going to plug into?
Put it into the L.
Yeah, that's really the easy one.
Yeah.
In other words, if I substitute 8 for W, then I get L is what? 24 plus 4?
Yeah, 28.
28.
Okay. These make a lot more sense.
Yeah. Once word problems become a lot easier once you realize that first step.
Once you realize they're just algebra.
Yeah.
Yeah.
And all of these are two variable problems, which means you're going to need two equations.
Yeah.
And go from there.
Okay, cool. Thank you.
You're welcome, Cody.
You had a lot. Yeah, we didn't have homework. She didn't give out any homework, but we're working on we just learned last class about the quadratics, and we're learning about it in standard form instead of vertex form.
Okay, cool. As far as Thursday's session goes, after the very first session where I verbally work you through the download of the software, the only thing you need for the next session is the meeting ID number. So what I usually do is just text it directly to the student's phone.
Cool, yeah, I'll save your number.
What is, well, no, it'll be a different meeting ID number.
Yeah.
Every time I have a session,
number,
yeah, I have to change the meeting ID number every time I have a session. What I'm looking for is your phone number. Because I'm not sure if I have yours. I may have just your mom.
Yeah, I just saved your number. Mine is 720.
Okay.
202.
Okay.
2737.
Okay, I think I do have that one, in fact.
Yeah.
So I'll put that in as your cell phone number, and then Thursday at the proper time, which I think is 4 o'clock, I will...
Or 4:30, I think, yeah.
Is that what I said, 4:30? Yeah.
Yeah.
Hold on, let me just verify that.
Yep.
Yep, 4:30.
Cool.
So at 4:30, I will text you that 9-digit number, and you should now see an icon on your desktop that looks kind of like this thing here. This GoToMeeting thing that I'm pointing at, the orange flower. You should have one of those on your desktop.
On my desktop? Okay. Yeah, let me just check.
Yeah, verify you have that.
Let me see really quick. I just have to, I can't move this screen.
Right, I know. You got to figure out how to look at your screen by minimizing the GoToMeeting so that you're not looking at my screen. But
there we go. Yep, there it is.
Just double click that before our next meeting, and it'll ask you for the meeting ID number. I'll give it to you then.
Cool. Thank you so much.
You're welcome, Cody. Talk to you Thursday.
Cool. Thank you.
Bye-bye.
Bye.